Hello, folks. Welcome to the second episode of the circuit theorem series. As we saw last time, we solved some properties. We saw some properties, and today we'll finish off with the rest of properties and solve more examples. So let's do a little recap. The last time we saw that if we have a chord and it subtends different angles at the circumference, and those angles are at the same side, then they are equal. So we had that x equal to y is equal to z. Secondly, we had that if we have a chord and it subtends an angle at the center and the same chord subtends another angle at the circumference, like we see in the diagram, then we have that E is equal to 2D. Thirdly, we had that in the cyclic quadrilateral, opposite angles are supplementary, that is, they sum up to 180. So x plus y is equal to 180. Then lastly, we saw that if you have a diameter, the angle is subtended at the circumference is 90 degrees. So today we start off with the fifth property. And the fifth property says that if we have equal chords, irrespective of where they are positioned, and they subtend angles at the circumference, then those angles are equal. So in the diagram, we have that this angle x is equal to this angle y. That's our fifth property. Now, the sixth property says that if you have a chord, two chords, and they are equal, the angle they subtend at the center are the same. So we have this chord and this chord. This line denotes that they are equal. Then we have that angle x is equal to angle y. Now, the same property. If we have a tangent to a circle, then the angle formed with the chord is equal to the angle at the opposite side of the segment. So this is one side segment. The angle formed here is equal to the angle formed in the opposite segment. So with this, we have that this angle is equal to this angle. Now let's go to the final property. With the final property, we have that it's just like the earlier one we did in property 3. This is a cyclic quadrilateral. Opposite sides sum up to 180. So z plus y sum up to 180. W plus x sum up to 180. And so we can say that opposite sides are supplementary, just like the first one. So this is just an extension of property 3. Now let's solve some few examples. Now let's look at the first example. In the first example, we have a circle with a cyclic quadrilateral, and we have a tangent CE, and AC is the diameter. So we have that the angles subtended at CE will be equal to the angle subtended here at angle CAB will be equal. Secondly, we would also take note that this is a chord, BC is a chord, DC is also a chord. So the angle subtended at B by the chord DC is 69. Similarly, the angle subtended here will also be 69. And as this one is also 31, the angle subtended at this point will also be 31. So with this in mind, we can now solve our problem. So like I said earlier, angle CAB is 31 from property 7 we have. Also, we have that angle DAC is 69 from property 1, cause subtend the same angles at the circumference. Now, if we want angle BAD, then since we know this side is 31 and this side is 69, we sum it up and we get 100 degrees. Now, we proceed. Now, we know that angle BTC is 31, like we've seen earlier from property 1, cause subtend the same angles at the circumference. Now, if I want to find angle BCD, what do I need? So I have this angle to be 69, and I also have this angle. What I need to do is to find this angle. But take note, since we are in a triangle, if I sum up all the angles here, I should be able to get 180. And we have that this angle is 31 because of this property, because angle CAB is also 31. So we have that angle BCD will be 80 using the sum of angles in the triangle. Now, we know that in the question we have CE is a tangent and AC is a diameter. So AC is a diameter. So the angle subtended at B, the total angle subtended at B is 90 degrees. So if we want the other half of the angle, then we have to find the difference between 90 and 69, and that gives us 21. Now, let's go to the second problem. If you look at this diagram, it looks a little complicated, but the solution is very easy. What do we know? From the diagram, we have that line AD is the same as line DC. And we know AD and DC are chords. O is the center. So what we know? We know that the angles subtended at the center by equal chords are the same. So this means that angle BOC will be 50. Now we have that. We have angle BOC to be 50. Then we will know that then angle AOC will be 50 plus 50. That gives us 100. Then how do we find Y? We know from property 2 that if I want the angle at the circumference, I have to find half the angle at the center. So Y gives us 50. Now let's proceed to our third problem. With our third problem, we've been asked to find angle OCB and angle BOC. Now, sometimes to solve the problem, we have to input our own variables, our own diagrams, our own extensions. For example, with this question, for us to proceed, you have to draw a line from A to C. So we are extending the diagram. This will help us to note that AC is a chord. Now from there, we can proceed to solve the question. Now we've been given that angle BAO is 32 degrees and AOC is 140. What do we know? We know that angle ABC is 70 degrees because of property 2. Also, we know that if I want to find angle AOC, OAC, then if I want to find AOC, then I look at this chord. It forms a triangle AOC. Then because this AO is the same as OC, then we have that triangle AOC is an isosceles triangle. This means that the base angles will be equal. Once I have the base angles, I can find them using the sum of angles in the triangle. And that gives us angle OAC to be 20 degrees. Now, once I find angle OAC, I intend to find angle OCB. Now, to find angle OCB, I take the whole triangle into consideration. Now, I have this part to be 32, and I have this part to be 38. I have this whole part to be 70, and I have this part, this is the part I'm looking for, and I have this part to be 38. So with that extension in mind, I apply the sum of angles in the triangle. Then we can now find an angle OCB is equal to 38 degrees. Now, to find angle BOC, what do we know? BOC is the angle at the center. Take note, once we extend AC, it will be that BC is a chord that subtends an angle at A. So that means to find angle O, and the angle at O, that's angle BOC, I have to sum up the 32 with the 38 degrees I have gotten. And I have to multiply by 2 based on property 2. So I have that angle BOC is the same as twice 32 plus 20. And this gives us 104 degrees. So now, as time permits, will not permit us, we cannot solve so many examples. So I encourage you to solve more problems. If you have some questions, you can send it to me via email, or you can leave your comments below. And do not forget to subscribe to my channel. Until we meet next time, thank you.